In this video we will solve exercises 4 to 6. So, exercise 4. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value 108 in this equation? Okay, and we have here some four answers. So Kathy will complete the repairs within 108 days. Not really. If days, well, D is the number of days she has worked that week, so it can be up to 5 probably, or 4, and because after 5 it actually is the number, it is a negative number, so it doesn't really have sense. Kathy starts each week with 108 phones to fix. Yes, when it's Monday, she has worked 0 days this week, so D equals 0. So 108 minus 23 times 0 is 108, and P is the number of phones left. So in the beginning of Monday, she has 108 phones that are left. So it will be the answer B. But let's check C and D to be sure that we didn't miss something. Kathy repairs phones at a rate of 108 per hour. No way. This way, after 1 day, after Monday, the formula says that she has 108 minus 23 times 1, so 108 minus 23, so 85 phones. So if she would work 108 per hour, repair 108 per hour, then after 1 hour she would have 0 phones, and that doesn't add up just. And D, Kathy repairs phones at a rate of 108 per day. Once again, no. After Monday, she would be left with no phones. The D would be the right if the formula was 108 minus 108 times D. Then D would be the right answer. For C, it would be more like 108 minus 108 times D times H, where H is the amount of hours worked every day. So that would be then the C would be the right. B is the right answer here. So exercise for answer B. Okay. Now question number 5. So we have some formula here, and which of the following is equivalent to the expression above? Okay, so we just have to simplify this. So let's write this exercise 5, and this is x squared times y minus 3y squared plus 5x y squared minus, and a new bracket, minus x squared times y plus 3xy squared minus 3y squared. So first of all, we want to rid of these brackets. So the first bracket doesn't really do anything. There is no sign, no number before this and after this bracket, so we can just take off this bracket. So it will be x squared y minus 3y squared plus 5xy squared. The other bracket, there's a different story because there is a minus sign before this bracket. So we have to change all the signs inside this bracket into the other one. So if we have minus x squared y, then it will become plus x squared y. Plus 3xy squared, it will become minus 3xy squared. And minus 3y squared will become plus 3y squared. And now we check what can we simplify. So minus 3y squared plus 3y squared, it cancels out. X squared y plus x squared y, it's 2x squared y. 5xy squared minus 3xy squared is plus 2xy squared. Of course, we cannot add those things because these terms are not the same. Here we have x in power 2 and here we have x in power 1. Just these things makes it impossible to add them. Also, y is in different power in both those terms. So let's check the answers, and this is answer C. So yeah, the answer for question 5 is C. And question 6, exercise 6. So once again, h equals 3I plus 28.6. A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a, in years between the age of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Okay, so some might say, oh, I don't know inches, I'm from Europe, I'm using centimeters, what are those inches? Well, what does it change? What does it matter? This is just a formula that is in inches, counted in inches, but it counts exactly the same as in centimeters or any other units of measurement. So it doesn't matter for us really what is this unit. Okay, so the question is how much it increase in each year. Well, we can see that h is a linear function of a. So height is a linear function of h. I'm not sure if it's very realistic, but definitely this model is very simple and easy to work with. So with linear functions, it's if you if you increase your x, your argument by 1, then the value of this function changes by its slope. It's the number that you multiply by the variable. Here our variable is a, and you multiply it by 3. So the slope is 3. So it changes by 3 for every change of 1 of your argument of a function. So the answer is A. If, for example, if you have a linear function and this slope is a negative number, then it decreases by this number. I mean, decreasing by negative value would be probably increasing, but yeah, if a is bigger than 0, if you have function f of x equals a times x plus b, so a linear function, and our a slope is bigger than 0, then function increases by a for every one change in argument. If a is smaller than 0, then it decreases by, let's say, the absolute value of a. So yeah, if it's, for example, minus 2, then the function will decrease by 2. And if a is 0, then this function is constant and it doesn't change at all, however you change your argument. So here, answer A. Thank you for watching my videos. If you like it, please subscribe and turn the notification bell and do all this stuff that happy viewer does after watching a video. And well, have a good day.